Okay. Now there are some important elements of any IoT architecture. So you have the functional elements, the extra functional element, that is additional things that are required. Okay, that maybe not directly that it should be mandatorily be made available, but it is desirable. This is what's called extra functional, and then some boundary conditions from outside that we expect should be there, that we need to take on board. Okay, let me discuss each one. I recall an exam question where I have our students discuss the functional and extra functional elements of a good IoT architecture. So if I ask such a question, these are elements that should be there. Okay, and in terms of functional, obviously in any IoT system it's about sensing. So your IoT architecture should provide the sensing capability. Okay, be able to capture data if possible in real time. Okay, hot puff, as we have seen. Actuation, we should be able, apart from capturing, we should be able to transmit information and do something. Actuation, we will have explained actuators with you, where we are sending, we are telling a door to open. This is actuation. It can happen through a motor that you are telling now open, now close. Okay, there you should be able to implement your application logic, like when temperature becomes higher than so much degrees, we need to start an alarm. So this is called application logic. In your architecture, there should be obviously there is no communication of data. Okay, especially so it should have communication capability that goes up to the cloud, because we have seen most of our architecture the data goes to the cloud. At the end of the day, you should be able to store the information. So all these components of the IoT architecture on the cloud, you need to have a proper database, whether it is Firebase, whether it is different types of databases that you can implement on the cloud. Then your data, information, everything should be collected. You should be able to perform what is called analytics at the end of the day, because the data, if you're getting millions of data, you won't have a person looking at those data. It will be impossible. So your system should provide some analytics capability. So this is why I've been saying sensor system, IoT system, they are closely related to data analytics, because at the end of the day, the collected data, what do we do with it? We perform data analytics on it. So we have what is called vertical analytics, horizontal analytics. I'm not going into the details at this point in time. Then management of the resources, of your sensors, of your data. This is on the management side. And then your architecture should provide some API that allow application developers to be able to program the services, the advertisement, the discovery of the devices and everything. So these are the functional capabilities that any IoT architecture, any IoT system should provide. Okay. Now let's look at the extra functional capabilities. Okay. So these are desirable characteristics. We can say non-functional requirement. Dependability should be there. That is, whatever architecture you are proposing, it should be reliable, it should be secure, it should be safe, it should be always be available. Okay, it's not that the system is down most of the time. So if it is okay, then it is not dependable. You cannot depend on such an platform. Okay, then obviously performance and QoS are very important requirements. Okay, the response time should be very good, so as your users can know what is happening on the fields, the temperature changing, the humidity, depending on what you're monitoring, the response time should be very good. Latency, we have talked about it. Okay, low latency, we always try to achieve lowest latency. Okay, the timeliness of your system. Okay, it should be done in a timely manner, the data transmission. Resource management, everything about memory, about computing power, about energy. So all these needs to be managed very well. Earlier we have discussed this word about interoperability. Your system should be able to work with other type of system, support mobility, even your nodes are moving and everything. So this word mobility there. And then managerial domains, like allow users or administrators to manage the overall system. So this is extra functional. Then some boundary conditions, like distributed systems, given protocols that are used, it should be able to support those protocols, network standards. Then you need to abide, like, you should not be violating the privacy. For example, it become a legal issue if you're violating privacy and everything. So these are boundary conditions that you should abide by. So these are the we can say elements that should be there in an IoT architecture. Let me continue. Okay, this is a generic one, a generic IoT architecture. Okay, so on this side, you see here your sensors, whatever you're controlling, measuring, or whatever. Then this is called the end nodes. You should have interoperable connectivity, one tower system connecting with another. You have a gateway for transmission, and then you have communication to the cloud eventually, because your data should go to the cloud. I have a better diagram that is showing all those components. Here it is. This is a full excuse me, diagram where you can see the many functional dimension of an IoT system. On this side here, you have the sensors, the end nodes, as we call it. Your architecture should provide some connectivity, sensors connecting with sensors, or sensors connecting with what we call a gateway. Okay, because we have to eventually connect to a cloud, to internet. So, but the sensors will not have the capability of connecting to internet directly. It transmits information to a gateway. The gateway have capability of transmitting it to the cloud. So this is why I say gateway, and then communication to the cloud here. Now, communication to the cloud, we use different types of technologies that are possible there. You have GSM, your 4G, 3G, 4G, LTE. Then you have Sigfox, LoRa. So all these are long distance communication. And then eventually the data goes to the cloud. This is the cloud platform. These are the 4 popular cloud platforms after you will introduce. AWS, Google, Azure, and Watson is from IBM. Azure is from Microsoft. Google is IoT from Google. AWS is Amazon. Okay, and then on the platform now, you need to have a application layer support for you to develop your mobile application where you can visualize your data, you can observe, you can track, you can do all those things on the application layer. Okay, so this is a typical the layers of an IoT system. Let me continue. This is again from below here, the assets layer, your sensors, whatever, the resource, communication, data, then the application layer, and then the business logic is implemented on this side. And this cut across all the layers. Security, after you, everywhere there should be security, management of the different resources. Again, this is the same thing, nothing much different there. It's showing you the device layer, your sensors here. Network layer is the communication part. This is the support application layer, providing services. And this is the IoT application, actual IoT, where you're visualizing your data and everything. Okay, so now that I've given a brief overview of the generic architecture, I will discuss with you 4, not discuss in detail, but introduce to you 4 actual platforms that is being used by in the industry, that is being used by different companies. So let me start with Azure. Okay, Microsoft. This is a Microsoft product. You know, all those big players, they know that IoT is very important. They know that different businesses, whether it is, I don't know, it is a different companies, whether it is banks, you have petroleum company, you have for health, in health sector, clinics, hospitals. In all those sectors, there is use of IoT. So this is why those big players, they are providing a platform. Okay, they are providing a whole platform that cover all these. Okay, everything from sensors, connecting, gateway, cloud, analytics, mobile. So everything can be done on their platform. So let me start with Azure. Okay, Azure, Microsoft obviously is one of the major players. They provide a platform called Azure IoT. In their Azure platform, there is something called Azure IoT that allows you to connect sensors very easily. They say here, deploying IoT application for the most common type of use cases, such as remote monitoring. You have some temperature sensor you want to connect. You want eventually the temperature in your house, for example, okay, goes to your IoT platform, and you can monitor what is happening with respect. Or you have an IO sensor that is detecting presence of people in on the system. So very easily the data are transmitted, and you can analyze the data on the cloud. on the cloud a platform. So Azure basically provides such a platform. So and most of the, yeah, this is something you should be aware. Most of the platforms that I have discussed, that I will discuss with you, they have a plan and budget appropriately through a simple, predictable business model. Very often it is pay per use. Pay per use means it depends. Okay, maybe I can put the question to the close. How do you think those companies, whether Google, Microsoft, whether Amazon, will charge you? Because you are connecting your sensors to their platform, and eventually your data is going on their cloud service, and you are accessing the data from their cloud. How do you think they will charge you? Let me have I think Yuvraj Sigulam. How do you think those companies charge you?
Maybe on a pay-as-you-go basis.
Yeah, exactly. This is the term that they use very often. A pay as you go. Pay as you go. The concept itself. This is why I wanted. I'll put the question. So as we get this idea, pay as you go means it depends on the amount of data you are transmitting. You are transmitting more data, they will charge you more. If you're transmitting less data, they will charge you less. Okay, this is a kind of model they use. It depends on the amount of data that you're transmitting. And you see here, grow and extend solution to support millions of assets. Okay, you can connect millions of sensors there. Let me continue with Azure. This is their platform. On this side here, you see the devices that can support. You see here, Autos, Linux, Android, iOS, Windows, whatever your OS, your platform, or your devices are using, it can support it. This is the device, the connectivity. Eventually, it needs to be able to connect to a cloud platform. You have what is called a field gateway that allow you connect to the cloud, a cloud gateway. They use the concept of hub there, event hub. Okay, depending on what is happening, which logic should be triggered. This is the event hub that will tell you. And here, depending on what protocol you're to connect to your cloud platform, you can use all sorts of protocols. So and this is how they are implementing the concept of heterogeneity that we have discussed earlier. Not one type of protocol, but different types of protocol you can use to support different types of devices, different types of communication protocol. Then on the cloud side, you see, this is on the device side. On the cloud side, what they provide analytics, insights, different types of analytics, batch analytics. Okay, batch analytics will be related to something that we have discussed earlier. The whole clause, can you tell me? We are talking about batch analytics. It is related to a concept I have discussed with you today. When we say that it is performing batch analytics. Yes, anyone?
I think it is a cold pour.
Yeah, exactly. Cold puff, where batch analytics means it is not real time. Okay, cold puff means it's not necessary that it is done immediately in real time. This is called batch analytics, and obviously visualization and everything. Apart from this, there is HD insights. Azure ML. ML stands for anyone? Azure ML. Very easy.
Machine learning.
Obviously, it is machine learning. So it provides you with the capability for you to analyze your data using machine learning. Power BI. BI stands for anyone?
Business intelligence.
Yeah, obviously. Okay, Power BI. This is a product of Microsoft, where allows you to again derive useful insight from your business data. Let me continue. Yeah, you see now there it was batch analysis. Here you see hot puff analytics. So now you should be able to understand, you know what is hot puff analytics, real-time analytics. As the data is coming, immediately it is analyzing it and taking decision and triggering alarm or whatever. This is called Azure Stream. It's done by Azure Stream Analytics. This is hot puff business logic. And on this side, you see here, it is broken into three parts. The device side on this side, here the analytics on the cloud, and you see on the other side, presentation and business connectivity. Okay, this is what you have. You develop a mobile application that allow your users to view what is happening with respect to your data. Everything that have to do with the visualization, access your data, show graph about your data and everything. This will go on this side here. The presentation the presentation layer. There is, I don't know whether you are aware, there's something called Microsoft Dynamics that allows you to do it. So this is a Microsoft product by Azure IoT. As you see, from the sensors to the cloud and to your mobile application, it covers the whole spectrum, the whole ecosystem. Let me proceed. This is showing the same thing, but in terms of the specific component. You see your devices on this side, IP capable devices, your transport connectivity on this side, the cloud on this side, or the storage. Okay, the data needs to be stored. There is analytics that is performed using machine learning, whatever, and the presentation layer. You see the data visualization and presentation. For devices, it supported various kind of devices. For the connectivity, it used what is called event bus that support different types of protocols that is respecting this heterogeneity. For storage, at the end of the day, large volume of data needs to be stored. Very often it is unstructured data and everything. So you have SQL database, you have a document DB and everything that is used for Microsoft. And then for the analytics, I've already told you machine learning is used, stream analytics for real-time data analytics. There's something called HD Insight in Microsoft that allows you to analyze your data. And the presentation layer, I've already mentioned Power BI. Mobile services is provided for you to develop your mobile application where you can visualize those data. So all these are IoT services that is provided in Microsoft Azure. Obviously, you need to pay to use the platform. Okay, this was the first one, Microsoft. Okay, let's move on to the second one. You will notice something. All the platform, they provide this device, connectivity, storage, analytics, and presentation. You will see those things repeating in all the platform. I want you to observe this. Let's move on now to Amazon. AWS stands for Amazon Web Services. Okay, it's very popular. AWS IoT is a fully managed cloud platform that lets connected devices easily, securely interact with cloud application and other devices. So you connect your sensors, you extract the data from your device, take action with rules, you implement different rules. We need to trigger an alarm, we need to open water, close water, open a door, close a door, whatever. You can create web mobile application that interact with those devices. So you see here, AWS also provide you with all those services. You will see the different components here on this diagram. This is at the device layer, device level. This is a securely communicating to a gateway. We have not reached the cloud yet. Okay, to a gateway. The gateway transmit to a cloud platform. Okay, on the cloud you have your AWS services where you have all your analytics and everything. Transform messages based on rules and route to AWS services. On the AWS services, you have everything that have to do with your analytics and storage and analytics that will be provided there. Okay, and then eventually you have your applications, whether on your mobile phone and everything. You have your data for the data visualization, for you to visualize your graph for your data and everything. You see those things repeating again here. This is a scenario. You have your sensors monitoring of plants when connected farm, monitoring of plants and everything. Okay, this is an actuator. If we see that humidity is very low, the soil is lack water, so eventually we are monitoring those data. It's sent to our AWS IoT. Then we have a control automation system, the storage on this side, and we trigger this. Here there will be an action that will be triggered. We transmit an information to the actuator to start water, to start irrigation, for example, if the soil is lack water on this side. So you see, there is analytics, data storage and analytics that is performed behind on the cloud, and there is someone administering the system. This is a control automation where the logic, the rules are implemented. All this on this side, it is on the cloud, right? This side, it is on the cloud. Maybe one part, the visualization we are not providing, but just monitoring and performing something on an actuator. Okay, you can see it here as well. Devices connecting to a cloud, our cloud platform, IoT rules implemented. These are the database. DynamoDB is used on AWS, Amazon Web Services. Your AWS users on this side. There's a whole ecosystem. This is the AWS. It provides you with all those services, all those components in its IoT platform. So if you want, you have development tools that you can use to develop your IoT system, or your networking on this side, the analytics after you, okay, machine learning, QuickSight, all these are products from Amazon that you can use. Obviously, you have to pay for it. You have storage, okay, storage devices or storage components, application services, okay, hubs. You have mobile services. You have databases, all sorts of databases. DynamoDB is one, okay. Enterprise application for you to develop whole enterprise system. So all these are services available on AWS, Amazon Web Services. Obviously, you need to pay depending on what you're using. Okay, again, these are the different components that are already implemented on AWS. Let's see some of those components. IoT Thing Wind Farm. I see IoT Thing Camera. If you're doing some camera operation, you will use this one. IoT Thing Car. Okay, travel on this side. Okay, car, thermostat. So all these are components you can drag and drop and develop your application. This on this side you see protocol IoT MQTT. We are going to discuss this in a future chapter. HTTP is used on this side. IoT servo, the motor, IoT sensor, IoT actuator. All these are provided as component in the AWS system. IoT rule, for you to develop rules. If temperature greater than something, trigger an alarm or whatever, you can use this component to develop this rule very easily. You don't need to be an expert programmer to be able to do it. Okay, this was the second one. Let's move on to a third platform. Okay, you see some similarity between what we have discussed, Azure, okay, Amazon. Now we are going to discuss a product from a platform from IBM Watson IoT platform. So it combines what is called the IoT, okay, connect devices, gateways, and endpoints, okay, to a platform, a cloud platform called Watson. IBM, its cloud platform is called Watson. Watson, there's something called Watson Analytics and everything. So apply cognitive, yeah, they use the word cognitive here, cognitive technologies to help change how we approach and understand the world's information, that is data. To give what is called IBM Watson IoT platform. So it is a platform of platforms, okay? It implements security, rich integration of all sorts of data. So it's a comprehensive platform. Whether you want to do web programming, mobile, anything, you can use this one. So these are the 4 components that it has in the IBM Watson IoT platform. It has a component called connect and manage devices. Everything, your networking, gateways, anything will pass through this connect. It provides a component called analytics. Obviously, all your analytics, gaining insight from using real-time predictive cognitive analytics will be done by this side. Information management is management of your resources, storage, reporting, every visualization, everything will be managed by this component here. And obviously, risk management, it will manage the overall security of your system, ensuring you leverage the right information from the right sources, right software runs where you need. So this is the risk management that will allow you to do. I will take each one. This is the connect one. Connect and manage your IoT devices, all sort of sensors, heterogeneity, recall again, all sort of sensors, using different types of protocol. MQTT, HTTPS can be used at this secure communication and management, globally scalable. Starting with a single device, you can scale it to millions of devices. So this is the connect one. The analytics one, monitor device behaviors in real time analytics, drive automation, take necessary action, focus using machine learning, focus usage using machine learning, gain insight, analytics, become smarter about operating controls. So all this is done by this component. It provides a number of API, okay, that allows you, for example, to do natural language processing. If someone is talking, you capture, you understand, and you take action based on it. It allows you machine learning, for example. Okay, you have large volume of data, you analyze those data to predict what will be the next move, the next data, or whatever. Textual analytics, if you have a text and a message is coming, you can analyze it and perform analytics on the text. It will even provide you, I don't know, it's good for you to know if those features are available. For example, I don't know whether you were aware, on IBM Watson, even when you're talking, it can analyze your voice, whatever you are saying, and understanding and deriving meaning from it. This is something very difficult, actually. Human, we do it very easily, but for a system to do it, now we have systems that have started to do it as well. See this one, video image analytics. So you are capturing some video from somewhere, from some camera. It analyzes what is happening in the video and give you some idea about the scene, what is happening. It derives some meaning out of it. Again, this is a very challenging task, but IBM Watson is already able to do a good level of accuracy as well, providing for doing this. Then the next part is the management. Okay, improve visibility through dashboard, provide you with dashboard for data visualization, operate, analyze data from millions of devices. So this is the information management that will do it. Data storage, caching, transformation, all this done by this A component. Then you have one part on risk management. Okay, so everything obviously that have to do with your security. End-to-end core security features are implemented by this component. Okay, this is a scenario. For each one, I'm trying to give you a scenario. IBM, we have a weather application, taking it from different sources, scheduling safely, assets, failure, performance, whatever, for improved efficiency, performing predictive analytics, okay, predictive models, okay, correlate problems with weather, depending on what the weather condition, and analyzing it, and then trying to determine how weather condition impact on my devices, on my company, on my assets, for example, in order for actionable insights. Okay, so this was the third one. What we have seen up to now, 3 platforms. The first one was Azure. The second one was what it was. This one is Watson. The second one was Amazon. Okay, Azure, Amazon, IBM. Okay, now let's look at the fourth one, which is Google. Google Cloud Platform for IoT. There's something called Google Cloud Platform for IoT. Anyway, Google also is on the market for this one, okay, for IoT. It allows you a complete set of tools to connect, process, store, and analyze data, both at the edge. At the edge, we are talking on the sensor side, and in the cloud. Okay, the platform consists of scalable, fully managed cloud services that allow you to develop computing with machine learning capabilities, manage Android Things OS. Okay, so anything using a Android can be connected, used on such platform. And you see here as well, you have your devices, your sensors, the communication gateway, okay, the cloud, providing different sort of services, the storage, the analytics, you see on this side, data, cloud data flow, BigQuery, okay, and then the visualization, the application apps engine to develop mobile apps and everything on this side. Again, you see those components appearing. This is what is called the Cloud IoT Core. Okay, on this side you see Edge Engine, the analytics and everything. It uses Android Things or Linux. Okay, and then on this side this is the cloud, the data analytics in the cloud that is provided. Okay, and on this side the data usage. The main components, you have a device manager for restoring devices, configuring, and then you have the protocols that use MQTT or HTTP in order to connect to the devices. It uses a technique called PubSub. We are going to discuss this in one of our lectures, publish subscribe communication, because most of the time this is the type of communication we use in IoT. When we discuss, I don't know which chapter, IoT protocols, we are going to discuss about this one, publish subscribe strategy. This is just an example. You have devices transmitting data using the MQTT protocol to the cloud. On this side, you have a data broker. It goes using pub-sub communication on the cloud, and then it provides. This is the provisioner in terms of the data. This is an example again for build a weather station using Google Cloud IoT Core. So here you have these are using ESP32, ESP8266, showing to you that it is using different kind of hardware. These are microcontrollers. I think if you have done your assignment, you know these are microcontrollers using a MQTT protocol in order to connect eventually to the cloud. Okay, here we're using Cloud IoT Core, the pub-sub communication, saving it in a Firebase database. Okay, the storage, performing query using BigQuery. Okay, and then here we are visualizing the data, this application side on a web apps. Okay, here we have analytics, performing analytics and visualizing our reports and showing it to the user. So you see the whole ecosystem repeating again. So I had a small video on this one. I don't know whether you will be able to hear the sound. You tell me whether you're able to hear the sound now. Okay, are you able to hear the sound?
No.
No. Let me see. I don't recall last time how it was possible. I had a copy of the video as well. Are you able to hear the sound? No?
No.
No, still you're not able to hear the sound. Let me see if I stop sharing, share specific window. Just give me 1 second. I'm trying to do something. Are you able to hear this? Yes? Are you able to hear?
No.
You're not able to hear the sound from the video.
No.
Okay, never mind. Okay, never mind. I can share the link. Let me share the link. You can see it later. I share the link on the chat. You can see it later. It is already there. So let me continue. We'll wrap up with the IoT architectures. So we have seen up to now Amazon, there was Azure, there was IBM Cloud, four main providers of IoT platform, IoT architectures. There is one that is called IoTVT, okay, from mainly, if I'm not mistaken, Intel, okay, main project, hosted by the Linux Foundation, okay, supported by Intel. They are trying to standardize a platform for any IoT system. Okay, this is the architecture that they are providing. Again, more or less the same, different layers. They are separating the different security, like messaging, like device layer, device management, and everything. So they perform at the base level discovery, connectivity, resource, and then protocols and everything. So they are trying to support like a Linux, Android, and everything. So these are a few things that they have in the IoTVT architecture. You can see it on this slide here. I don't know whether I'm sharing. So are you able to see the IoTVT one?
Yes.
Yeah. So I was saying that this is another platform, okay, quite popular one. Okay, it is supported by companies like Samsung and everything. I don't know to what extent it will become popular, but it's good to know about it. IoTVT, okay, it's had been here for quite some time. It's a new standard. They are trying to establish a new standard by which billions of wired and wireless devices connect with each other to the internet. So basically, forming Internet of Things. So there are different components that they're trying to implement in their security, the notification, device management, and everything. It all depends on how successful it will be. This is the stack, the software stack, what is inside IoTVT. It's only when you're doing programming with it, then you will use those different components. You see on this slide, we are comparing different IoT architectures. Some that we have discussed, like IBM Watson IoT, Microsoft Azure is there. Okay, Samsung SmartThings is there. Okay, so you can see a table comparing it in terms of the sensors, in terms of the gateway application services that they offer. Okay, so we have reached the end for the architecture side. Our next part is on the standards, IoT standard. This lecture is about architectures and standard. So by now, I think you should have got a good opinion about IoT architectures. What are the main providers? Very important. The most important slide for today, if you want, I put it again, is this one. This one. We have spent quite some time. No, yeah, this one. Yeah, we have spent quite some time on it. So, what are the requirements for such architectures, for IoT architectures, for sensor architectures? What are the things it should have? I spent quite some time in explaining it, and then we have given 4 or 5 examples of IoT architectures. I think this is it from my side for this part, at least. For the lab recall, we will have a lab session this week as well. We have tried with a LED on an Arduino board this week. Now that is last week. This week we will try to connect it on a circuit. Not one. We'll try to connect more than one LED and try to manipulate those LED. Switch on one, the second one first, and then increase the speed at which it is flashing. Things like this we will try to implement, but on a circuit. Once you know how to build a circuit, then later all my labs in the future lab will be on building it on a specific on a specific circuit. So I explain you how to power the circuit, how to interconnect the different components and everything. So on Thursday I have the graduation ceremony. So can I have both group early for the explanation, and then you can divide yourself for the we can have group B first for their a demonstration, that is their use of the equipment, and group A later. But then the explanation, is it possible to have all groups together, because I need to move for a graduation ceremony. So let me stop the recording here. Then